Hi, how are you doing? Can you see me?
Yeah, I can see you.
Okay, great. Well, there's a voice lag. So when your lips move and the voice comes, there's a lag.
Little lag. Okay, okay.
Yeah, there is a bit. So I would like you to give me your introduction, what you are doing, and how do you think my classes are going to help you?
My name is Dia Satish, and I'm here to get some extra help for next year's grade 11 IB course. So I just want to use your class to help me prepare in advance.
Sure. So thanks for sharing your book also. And you want to go as per the curriculum which has been assigned to you, right? So
Yep.
I've been teaching the IB program students for a couple of years, at least 7 or 8 years. So over the period of time, I have my own videos on those topics which are of your interest. So when we will be having classes, I'll be sharing with you my own videos and my material, right?
Okay.
I'll try to keep focus on your material and your curriculum so that, we are all right on the track and we do exactly what is required. That's the whole idea.
Okay.
So I will be referring to your book sometimes, so only just to tell you that, well, we are on the same page, correct?
All right. All right.
That's the whole idea. The idea is not to copy the book or just do that, right? The idea is to, because I'm a tutor, I have to answer your questions, which are from your book, right? So I can't help it rather than, use the material which you're providing me with. Another important thing is that, every day we can connect like this, but during the video session, let's keep it like on learning new concepts and getting the difficulties out of the way, right? So I can explain you all what you've not understood so far, from whatever we have done to help you move forward. So that really means that, these are summer holidays. What other activities have you taken up some school summer classes?
No, we're not allowed to do it this year.
Okay. So that means you must be having some time. It really depends how much practice you can do because IB program is a tough program, is one of the best in Canada. And to be on top of it, I know you are a brilliant student and you have been with me for a couple of years. I know that. But to maintain that level, you understand? To maintain that level, you have to work twice as hard you had been working earlier. So it's not that easy. Don't take it easy, right? All the students who have gone, Shruti recently, right? She's got admission into medical college.
Oh, wow.
Yeah. And so the students are doing fairly well. But I prepare them right in the beginning to work hard. Otherwise, it's tough. Okay?
Yeah.
So remember that. Now, I've already shared 2 videos with you. Just sent you on email.
I see them. I've seen them. Yeah.
Okay, good. So I'll make a separate playlist for you. So in that playlist, I'll put only those videos that you must be watching for sure, 100%, right? And then you can refer to many of my videos because I have hundreds of them. And I don't want you to get, lost in so many. So we'll focus on few so that we understand the concept fairly well. Okay?
All right.
Now, today we are going to learn about 2 things. One, we'll start with number system. After all, what is a number system, right? And from your notes, I saw they're talking about interval system also. So we'll touch upon the interval system and the number systems, right? Those are the 2 things which we are going to focus on. Okay. So in between, we'll get to your book and see where we are and then work out a few questions. Now, my request to you is that once our class is over, you should sit down and do all the questions from your book. Okay?
Yeah, no problem.
No problems at all?
Yeah.
And wherever you get some difficulties, post me those questions we can discuss in this session. Is that clear?
All right, no problem. Yeah.
Chapter 1 is done. This is your chapter 1, correct?
Yeah.
So we have to go with like solid foundation. We can't leave anything for tomorrow, right? So doing chapter 1 means if anybody asks you any question, you should be in a position to answer. That's the whole thing, right?
Okay.
And that's only possible if minimal. You do all the questions from a book. Once you do that, I will give you my questions and the questions from previous test papers.
Okay.
Then you have mastered the topic. Is that clear?
Yeah.
So our
Alright.
sessions will include learning about the new chapter, one. Second, clarification on whatever we have learned.
Concepts.
Third,
Okay.
prepare for the test, and as we move on, we'll have our worksheets and quizzes going along, and so that you can do excellent, just
Alright.
as all other students, all my IB students have done. Is that clear?
Alright. Yep.
Okay, right? And
Yep.
you've seen most of them, correct?
Mm-hmm.
Recent, of course, recent ones, yes. Okay. Now, to begin with number system, we all started with natural numbers, right? The counting starts 1, 2, 3, 4, and so on, right? Then slowly some part of the world learned that there is a number 0 also, which was being used from ages in Asia, especially in India. So my video on this actually says about it. So read about Aryabhatta to understand their contribution, which has not been highlighted in this new world, right? So we actually give credit to many other people, but not to many real people who have contributed in mathematics, right? So I will take this opportunity to thank them, especially people like Aryabhatta, right? Okay, so you should read and understand about their contribution. So the number 0, which comes from India, extended this natural numbers list to whole numbers. Then basically the Western part thought, now this is all what we need, and these are called the whole numbers, right? The name suggests, right? The whole numbers. And soon they discovered that, there are some negative numbers also, like temperatures, you see negative, and negative 30 going on. So they extended this list to integers. I mean, come on. And then they came across some other words and they said, oh, what is the square root 2? These Egyptians have been making some drawings like 1, 1, and they get this hypotenuse equal to square root of 2. What is this number? And they said, okay, so we'll give that name also. So they came up with another set of numbers which are called some numbers, right? Real numbers. Okay. So then in between they talked about fractions. So they gave a name like the fraction should be called as what? Rational numbers. They thought this is not rational. So they very methodically gave some new names to them: natural numbers, whole numbers, rational numbers, irrational numbers, which were not fitting into their criteria. And then they discovered, so let's call them all real numbers. Come on. So finally, we came up with a list of real numbers. Okay, so that's the beginning of number system. But go through it. And what is important to understand here is the numbers n written for natural numbers, w for the whole numbers. So can you now tell me the difference between natural numbers and whole numbers, please?
It kind of just gets into specifics, right? So aren't they kind of the same thing?
One difference, major. 0 is a part of whole numbers and not a part of natural numbers.
Yeah. Okay.
This is a very important difference. Many times in your questions, the question will be, provide solution to this equation in the set of natural numbers. So even if 0 is a solution, you cannot put that there.
Cannot add, okay.
That is not a natural number, it's a whole number. So if you put that 0 there, it will be wrong.
It will be wrong, okay.
So we have a set from which you have to pick the numbers. So as we go along in functions, we understand that this set on which you are working is always called domain in which you are working. That's your domain. So you are restricted to this particular domain, and always you have to pick up your numbers from that particular domain. The same question, for example, you have done already lines, correct? You say, my line equation is y equals to mx plus b, okay? I give some value to m, some value to b, and I say, let's keep it simple, y equals to x plus 1. Simple as that, right? So when I say the equation of line is y equals to x plus 1, you will draw a solid line, correct? Y-intercept of 1, slope of 1, and there you go, correct? But now I change my equation, and what am I saying now is, well, the equation of the line is y equals to x plus 1, where x belongs to set of natural numbers. Then tell me, how will you draw this line? Tell me.
So I first would probably make a table to input each of the natural numbers.
Yes.
And then as I follow the pattern, then I would draw my line based on that.
What type of line will you draw?
I think it wouldn't be a curve because it's not going to be a linear line.
It has to be a straight line, but will you make a solid line?
I don't think so.
No. So then what type of line will you draw?
A curved line?
No, just a set of points. And these set of points will be based on the natural numbers, right? Starting with 1. Do you understand? You will not put that y-intercept this time because 0 is not a part of natural number. So your line will begin with number 1, x plus 1, right? X is 1. 1 plus 1 is 2. So at 1, you get a value of 2. And then at 2, you get a value of 3. So 1 dot there, points after points. You're not going to connect them, okay? Just kind of a scatter plot as you have been seeing. That is when I say that the domain is natural number. You're getting into it. It's very tricky.
Yeah.
It's tricky. Now, when we work with lines, we are basically looking at a trend, right? Straight line. So what you could do here is you could connect these points with a dotted line. Do you understand? Dashed line. You get the idea? So you could connect them with a dashed line. It still indicates those marked points which were set of natural numbers. Correct? But never a solid line.
Solid line, okay.
Solid line means set of real numbers, which includes everything. Correct? Everything in between. Correct? So that is very important. So let us say we have two natural numbers, number 2 and 3. How many numbers are between these two natural numbers, number 2 and 3? Tell me.
Well, you can split it up into a lot of like smaller parts.
Natural numbers?
Yeah, into natural numbers. Okay.
How many natural numbers will you have between the number 2 and between the number 3?
You could have 4, I think.
No, because after 2 comes 3, there's nothing in between.
Well, we won't go into like 2.5 or like 2.
Natural numbers.
Natural.
That's clear. So I want you to focus and understand this set of numbers. When I say set of numbers, it means numbers starting from 1, 2, 3, 4, all these. No 2.1, 2.3 or something like that. Keep in mind, okay, because that is kind of students get confused when we talk about it because they're so used to real numbers that they don't categorically look into the set as we are talking. Do you understand?
Yeah.
Okay. Perfect. So, focus. When I say draw a line and now my line has set of integers, in that case, my dots will go on that left side also.
That's right, yes.
And they will also include 0. So as soon as I say integers, which is normally written by the letter Z, is that okay? So letter Z will give you integers as given in your book. Now, Z, the integers, sometimes we also write Z plus. When I write Z plus, means non-negative integers.
Non-negative.
0 included and on the right side of the number line. You understand? Integers on the number side, right side. Means
so Z represents your integers and Z plus represents 0 and your positive integers.
Like whole numbers, correct?
Okay.
Like whole numbers. Is that clear to you? Right. So that becomes Z. And then you have a letter Q. Now Q is called, now you have like quotient. You understand the quotient? One divided by the other. So we have been talking about fractions. Now these fractions are called rational numbers, right? 2 over 3, 4 over 5, correct? Those, so in between two rational numbers, you could have infinite numbers as you were trying to say earlier. You understand?
That's
correct. So that is the set represented by the letter Q. Q comes from quotient. That means you're dividing one number by the other. Make sense? Okay. Now, so if you could write a number in the form of A over B, for example, right? In that case, we say these are your rational numbers.
Rational numbers.
Right. Now, as I said, there are numbers which are not rational. And they're very tricky numbers, but very useful. For example, the number pi, right? You know what is the area of the circle? Tell me, what is the area of the circle?
Pi r squared.
Pi. What is pi? What is the value for pi?
Well, we use 3.14, but it just keeps going.
Keeps going and going and going. You
Yeah.
cannot even write this as 22/7. Well, to some extent, approximately, but not really, correct? So these numbers, when we came across, we said, well, these numbers cannot be written as a fraction. They are not rational quotient. I mean, whatever, right? They started calling it irrational numbers. But we don't have any symbol for irrational numbers. Do you know that?
No.
So for irrational numbers, what do? Okay, they write Q bar, Q and a bar on top, like complement, which is not.
Okay.
Normally a bar means not. So easy way, Q bar means not the irrational.
Rational. Okay.
Does it make sense to you now? Right?
Yeah, I'm getting it.
But there were too many important irrational numbers, like number E they discovered, and the square root, all series of square root, square root 2, square root 3, and so on. All these are irrational numbers. Oh my God, there are many, right? So they said, well, let's be real. Then, including all these numbers, we call our numbers as real numbers. Is that okay?
Yeah.
R, capital R. Set of real numbers. So I think you're getting hang of these set of real numbers and all of the numbers which we talked about, correct? Go through your book so that you really get, when you see it, you'll register, and all what we're talking about will make a lot more sense. Is that clear? Okay. So we have come to the real numbers. Can there be something not real, but numbers?
Not real, but numbers.
Hmm.
So, like, what do you mean by that?
Yeah, that's funny. So it came up, and so they said, oh, these are imaginary numbers. So we have another set of numbers which are called imaginary numbers, which are
You represent using the I, right?
I, yes. Because
I.
you understand, you done square root thing, right? When you have a quadratic equation, and then within the
we
quadratic
did a little bit of imaginary numbers.
square minus 4ac, right? Was it?
Yeah.
The square root is only possible if you have a positive number inside. You don't have square root of minus 4 because square of every number is positive. But you know what? There should be some number. So we call them the imaginary numbers, where I squared is -1. So that opens a new chapter for us. And we say, well, this is imaginary numbers, include it all above the real numbers. Is that clear to you?
Yeah.
So we'll close here at this moment. We'll say these are our numbers to work with. You're going to work with imaginary numbers a lot next year.
Okay.
Not this year. So don't be afraid of that.
All right.
So at present, we'll just keep it simple. We might introduce you to imaginary numbers slightly at the later stage when solving quadratic equations, right? We'll introduce iota to you. Perfect. So is that everything clear so far?
Yeah, so far we've learned the definition, so yeah.
Everything is clear, right? So I think I haven't really missed much. Let me just check with your book. Let me share the screen and check with the book if I have really covered everything. So can you see your book here?
Yeah, I can.
Number sets. So let's go through this. So when they talk about set, we have these curly brackets. Do you see this curly bracket?
Yeah.
So now let's talk about set. A set is a collection of objects or things. Is it okay? As written here. And we will always write a set within these curly brackets, whatever goes in between. So every set will have a name, and normally the name of the set is given by a capital letter. For example, here they're given V for vowels, and A, E, I, O, U are the 5 vowels given in curly brackets. They form the set, correct? Similarly, you could have set of so many things to begin with. We can have even numbers, odd numbers, and things like that, correct? Multiples of 5, something. Set of natural numbers we had been talking about, set of whole numbers, set of real numbers, set of irrational numbers, something like this, correct? But important thing is you will write it within curly brackets as given in your book. So follow that notation. Is that clear to you?
Yeah.
Now, using this notation, N and n, the number n which is they have written before v. So earlier they have said that v is the set of vowels a, e, I, o, u. So if I write how many are there in this set, we write n and then brackets. So in this set we have got 5 elements. So these numbers individually are called elements. Is that okay? Now this set of elements could be finite or could be infinite. For example, if I say set of natural numbers, well, the list goes on and on. We have an infinite set of numbers. Is that clear to you? Correct? So that covers up this topic, finite and infinite set. Now we have also used the symbol which is E, right? It is called belongs to, right? So that's the nomenclature. So in set notation, you have to be very particular about using all these symbols, right? And you should also be very careful when to use capital letters and when to use lowercase. For all variables, normally we prefer lowercase, right? And for the names, we prefer capital letters. For example, the letter V for vowel and E for even numbers they have used in your book are all capital letters. Is that clear to you?
Yep.
Number of alphabets you know are 26. So if I say that is my set of numbers to work with, right? When I say numbers, it could be anything, right? Not necessarily numbers, correct? So I could use English alphabets as my numbers, okay? And then we have got 26 of these. So we'll say, well, capital A is my set of alphabets, and capital A will be 26 number of alphabets within my set. And each individual is called an element. Is that clear?
Yeah.
Now, let us say we are talking about vowels, and if I say P, now P is not a vowel, so we'll say P does not belong to my set of vowels. Do you understand now? Correct? So that belongs to symbol. If I cut it across, means it does not belong to. Correct? So that is how you have to understand these numbers. Okay. Now, the best way to represent all these numbers is definitely a number line. So on a number line, if I mark numbers on the right side of 0 as 1, 2, 3, 4, they will show you this set of natural numbers. Correct? And if I include 0, it will become set of whole numbers. If I include the negative side, -1, -2, it becomes integers. And if I use my fractions, rational numbers, everything in between, real numbers, right? So any dot on a line can be represented by a number, and that number is called a real number. So in real sense, what are real numbers? Real numbers are numbers which can be represented on a number line. Is that clear? Okay. Now moving forward, you have seen in this diagram that we have a number line in red and some circles in green, which are like solid circles. Right, so that means that number is kind of marked and included. Soon we will also see number lines with open circles. So sometimes we have to write solution of an equation or inequality or something where we might mark the number line with the solid circles filled in, or with circles which are open. So if the circle is open, not solid, okay, it means it is not a part of your solution. Is that clear to you?
Okay.
But if it is closed, solid, it means it is definitely a part of your solution, right? So it is important to understand at this time, because if I say numbers, real numbers greater than 1, in that case, 1 is not part of my solution, but everything on the right side is what to do. I will make open circle at 1 and an arrow towards the right, indicating 1 is not a solution, but everything else on the right side is. Does it make sense?
Yeah.
If I say numbers between plus and -1, between not including, in that case, both will be open circles, and a solid line in between indicates set of numbers in between those two limits. Okay. Now there are other conventions also which have not been explicitly mentioned here, but I like to tell you, since we are going to use material of different kind, and everybody everywhere is using different type of conventions, so we should be familiar with that. Correct? After all, your curriculum is an international curriculum. So sometimes what we use, parentheses, right? So the open parentheses are written by those parentheses, right? But if it is closed, then we use square brackets.
Okay.
So the square brackets means on a number line that number is included. But if it is not a square bracket, but this parenthesis, then it is not included. Is that okay?
Yeah.
Whenever I'm writing an arrow going this side with the arrowhead, it means it is going to infinitely large value.
Okay.
Infinity cannot be included because you can never reach it.
Yeah.
So if I want to say numbers greater than 1 in parenthesis form, correct?
Yes.
Then this will be like an open circle at the end for infinity.
Okay.
Do you understand?
Yeah.
If I say all numbers greater than equal to 1, then 1 will come with a closed bracket, square bracket.
The other will be a square.
Other will be open. Do you understand now?
Yeah.
So that is how you have to place the numbers. So I think that I have completed those things which are missing here. That's just a good thing to refer to, right? Now there are real numbers, and within the real numbers, they have mentioned numbers like fractions and square root 2 and pi, right? You see that? So those two are actually irrational numbers, but irrational numbers are included in the set of real numbers. Perfect. Now here is a good note which I should tell you at this moment. We're talking about rational numbers as numbers which could be written in the form of a fraction, correct?
Yes.
And you also see many times decimal numbers which repeat. For example, 0.33333, recurring, right? Recurring, repeats. Now these numbers can be written in the form of a fraction, and therefore they are actually rational numbers. Okay?
Okay.
Yes. But if after decimal we don't have a repeating pattern, right? In that case, it is irrational. So for square root 2, you can just check on your calculator. Nothing repeats there, right? As they have mentioned some values, which is 1.41421356, nothing, no pattern.
Then that's irrational.
Irrational. You get the idea now?
Yeah.
But the numbers were like 0.3636363. You see a pattern, correct?
Yeah.
Now this number where there is a repetition, we can always write this number as a fraction. Example 1 indicates the technique of doing so.
Okay.
So the idea here is that you have this number in example 1, which is 0.36 recurring. So there are 3636 is recurring, right? Also important to note, you should not say 0.36. It is 0.36.
Yeah.
Right? So, okay. So 3636 recurring means it repeats. If I multiply by 100, it becomes 36.363636. Do you see that?
Yeah.
So earlier I had 0.363636 multiplied by 100, I have 36.363636. But if I take away from 100 the other number, then everything after point gets cancelled away. So I got just 36, but 100 minus that one number is 99x. You get the idea?
Yeah.
So look at the solution once again. It says let x equals to 0.36 recurring. In that case, 100 times x will be 36.3636 recurring. 100x minus x is 99x. And you're left with the number 36. Those decimal numbers which were repeating have vanished. So x is 36 divided by 99.
Okay.
You could write this as a fraction, one over the other, and therefore it is a rational number.
Rational number. Okay.
So watch my videos on how to convert different kinds of these repeating numbers into fractions and how to decide whether a number is rational or irrational. Is that okay? The symbols given here clearly that q, it says 3 over 4 belongs to q, right? And square root 2 doesn't belong to q. That is correct.
That is correct. Okay.
Right? So likewise, you can answer all these questions. Wherever you have any difficulty, you can always text me. I'll also like you to share with me, share with me your WhatsApp number. Sometimes
I'm already in the group chat.
Okay, so send me a message there, then I'll then any question immediately, I can just answer and do it.
Okay.
It's very fast, okay? Getting on to a Zoom session takes a lot of time.
Our time, yeah.
Yeah, so that is clear to you. Now we'll talk about interval notation, which I have actually shared with you a very beautiful video on interval notation. After this class, I'd like you to go through that video and understand how do we represent inequalities using interval notation. Is that clear?
Yep.
Okay. Okay. Anyway, so interval notation, again, you begin with the set. Whenever you have these curly brackets, that means set of something, correct? So in this case, interval is also a set of something. Perfect. So therefore, it is saying interval or set notation. So we have to represent it in some way. When they use curly bracket, they call this as a set notation. You can also represent interval with the help of inequalities. For example, you can say as written in between. You see in the in between, we have mentioned here this portion, which is -3, where x is greater than -3 and less than equal to 2. So that inequality independently can also represent an interval, okay? Without curly brackets. If you use the curly brackets, we call it set notation, right? And there is another notation which we can use, which I was talking about, those square brackets or normal parentheses, okay?
Okay.
That is called interval notation. Is that clear?
Okay.
So in general, that is called interval notation, but when you put it in with curly brackets, it is called set notation.
Okay.
So be clear about these definitions. They are very critical. Because if the question mentions that you have to provide solution in this particular notation, you have to write notation.
Yeah.
Okay? The number line is the easiest way to show the interval. So if you have filled in circle, which is here at -3, can you see that?
Yep.
Included. At 6, not included. Open circle. You see that?
Yeah.
So we have set of real numbers represented in part B. Everything in between -3 and 6, where 6 is not included. Do you see that?
Yeah.
X is greater than equal to -3, but less than 6. And X. And what is this straight line called? Can you tell me?
Oh, I don't know where your cursor is.
This straight line.
Isn't it absolute?
Such that it's a condition. So if you look at this set notation once again, parenthesis tells you everything in parenthesis is the set. X such that, we say X such that, or the condition. X such that X is greater than equal to -3, but less than 6.
Oh, less than 6. Okay.
6. That's what you have to read. Is it okay? Now, in the very first one, we only have some dots, not a solid line. We're talking about set of natural numbers. Remember, we can also call this set of integers. No harm done. Integers include natural numbers. Integers include whole numbers, correct? You could also write z plus, because these are natural numbers, right? Okay, so that makes it clear. I think we're done with this exercise.
Yeah.
So you can do the rest, Venn diagrams. Okay. When we talk about Venn diagrams, we have something like everything included, which is called the universal set. Okay. So normally to represent the numbers, we can just make a box. We say everything in this box is my universal set, right? Universal set is normally given by the letter S, space. That is my space to work with. You may write U for universal set also, right? You could do that. Your book uses S. Okay? Yeah. So you use S, and as I was saying, a dash, S dash means complement, not within this set. Is that okay? So that is a convention. Correct? So let's go through this definition. A Venn diagram consists of a universal set U represented by a rectangle and sets within it that are generally represented by circles. So we have a rectangle. Within rectangle, we could make many circles. Okay. So those are individual sets, but the rectangle represents the whole set, universal set, or the whole space. S letter can be used on the side. You look into my videos to see how to write and where to write. Well, here is an example. So this particular rectangle, which has got a boundary of green color shaded in light yellow, is your space, right? And now we are writing two things. We are writing the letter U, which means universal set. For U is 1 to 10, these numbers. Okay? So let me read the question, as this is very confusing. Draw a Venn diagram to show that the set S is equal to curly brackets 2, 4, 6, 7 within universal set U. So that means initially U was a universal set, not S. Okay, so for you, I'm sorry, I thought they're using, I didn't read the whole thing, right?
Yeah, okay.
Your book is using U for universal, and S is not this space, okay?
For specific
but in some books, you will see S as your universal set also. Is that okay? So we'll maintain A, B, C, D, and S as one and the same thing. So for convenience, they've used the letter S for sets. Okay. I'll prefer you to avoid it. Okay. So whenever there's a set, try to give any other alphabet capital letter than S. S can be confused with the space, which is universal set. Okay. Let's get back to the example. Where were we? This one or the first one? Okay.
No.
This one. Okay. Anyway.
No, we passed that.
Okay, it doesn't matter. Let's look into this. So do you see the Z plus there?
Yep.
That means what? Tell me.
Z plus means integers.
What type of integers?
Natural numbers or whole numbers.
Whole numbers. Non-negative integers. Very important, right? So non-negative integers. That is Z plus. And what is the meaning of this E prime? Complement. This is called complement.
I've never seen it.
So what we said was, let's go back to this particular example. The set S has these elements, which are 2, 4, 6, and 7, correct? We are saying the set S has elements 2, 4, 6, 7. And S is 1 to 10, which is not S, means everything outside this. All other numbers, not these numbers, right?
Okay.
So complement. So that is the meaning of that prime. Clear?
Okay.
Then they've used this convention N E complement. The number, the elements which are not part of S, right? Or E in this case, right? So those numbers, 1, 2, 3, 4. 4 numbers are outside. That's what they're trying to say.
Yeah.
Number of elements in your universal set here is 10.
10.
Got the idea now? So, not difficult at all. It's very systematic.
Yeah, this one's pretty well, yeah.
Easy, right? Okay. So that's how you have to do all this. So I think you will go through these examples. They should not be difficult for you to understand. And if there is any difficulty, you can always ask. Okay. Now, I think now we'll move on to. Now, as they were saying, that set can have a rectangle, and within a rectangle, we could have a circle. So circle represents all of the different kinds of sets. But you could have many circles. You could have circles within circles. You could have circles which are not touching. You could have circles which are touching and overlapping. So any way you could make it, correct? Now, if you have a circle within circle as shown here, it means subset. Means that the bigger circle includes everything which is there in the smaller circle. To give you an example, natural numbers is subset of whole numbers. Whole numbers is subset of integers. Integers is subset of real numbers. Does it make sense?
Yeah.
So one circle after the other. And I think that's the diagram in example 5. So that's what they're trying to share with you in example 5. Okay? N for natural numbers, Z for integers, Q for rational numbers. Correct?
Rational.
And outside, real numbers. Do you see that real R outside?
Yep.
So the universal set of real numbers includes all of them. Clear? The next example, we are overlapping two circles, and overlapping really means something in common, intersection. Okay? So in this particular case, you say set A and set B, and they're overlapping. 3 and 7 are common to both. So when you represent this information in the set form, you make circles like this and put the common elements which are common to both.
Okay.
Clear? So here, the universal set they are saying is all the numbers from 0 to 12, all the numbers, and set A has the numbers 2, 3, 5, 7, 11, and B has 1, 3, 6, 7, 8, right?
Okay.
And then they're saying what is common? So you'll see 3 and 7 are common, and they are now represented here in the center. Is that clear to you?
Okay.
The numbers which do not belong to A and B are outside.
Outside.
Is that clear to you?
Yeah.
Have you got all this?
Yeah.
Easy, right?
Yeah,
No.
it sounds not too bad.
Okay, so I think you can do this exercise without any problems. And just as we were working with 2 sets, you could also work with 3 as given here. Clear?
Yep.
Now, let me share with you, I think, my videos. If I... Okay, so let me share with you my videos so that you understand what we are talking about, okay? So, I'll actually prefer you to follow my videes. And of course, you have to do your book. We'll always be checking on your book only to see that we are not missing anything, right? And sometimes we'll follow the conventions used in your book. Clear? Right. So, well, this is the second video in the playlist which I just added or created for you today. So here we have an example. We are saying some basic examples, set, interval notation, graphs, and we are actually solving inequalities, double inequalities, and so many other things. Well, most part of it will be relevant after a few months, okay? But at least the first part of it is relevant. So you should watch at least half of the video to understand the set convention. And here, with the help of a number line, I've already shown you what we were talking about, correct?
Yeah, the circles.
Right, circles. Now remember one thing, why my video is important for you is, on one page, I'm giving you 3 conventions. I'm saying
Set, interval,
and graph. Right? Set notation is when you put those curly brackets, that's the set notation, correct? Then you have interval notation when you put parentheses or the square brackets. And that is also correct solution. The third one is a number line. So you could always represent the information in any one of these 3, if not specified. Is that clear to you? You should be very clear that when I write x is greater than a, means x is on the right side of a is not included. And we have this bracket on both the sides. But when I say, let's take this one, which is x is greater than equal to a, but x is less than b. That means a square bracket comes with a, right?
And the round with b.
Perfect. That is what it means. So b is not included, but a is included. So we'll fill this up. We'll fill this up, right? Yeah. So likewise, you could actually look into this. So when you go through your chapter, it's kind of important for you to look into my videos and get a fairly good picture. I mean, global picture of it, right? Right. That's kind of important. Now on the set theory, I'll just search Anil Kumar. So you have to type in my name, of course, to just find my videos.
Yeah.
So say set what we want, Venn diagrams. Okay. So I have questions from previous test papers, and normally, let me write playlist also here. So I want you to get conversant with using my videos. So you can search by typing Anil Kumar Venn diagrams playlist. As soon as you do that, you see one set here. Somebody else has Irum had been my student, GCSE. So she found my videos very interesting. So she has made her list using my videos. Okay, so Now here we have Venn diagrams, right? So you can go through these Venn diagrams once you do exercise in your book.
Yeah.
Perfect. So for example, this Venn diagram has got 3 circles, and you can, once you understand what intersection means and how to work with them, we are using S for the universal set. Do you see that part?
Yeah, instead of U.
Therefore, avoid S naming your set. Is that clear to you?
Yeah.
Space. S is for space, and many books are using S for space. So it is kind of very important, right? So a playlist in this case will have so many examples. You can actually go through these examples. The idea is, if I write something like this, it means if NA means number of elements in A is 15. Do you see that?
Okay, yeah.
Number of elements in A is 15, and A union B. If number of elements in A or B, both together is 30, and number of elements in A and B means intersection in between is 7. Find the number of elements in B. That is the real test question.
Okay.
Which you will normally see in a test paper. So the idea here is follow your book, but always find time to watch my videos, and that makes a difference. Okay? So if you go through this list, you'll find your exercise much simpler, right? Easy to do. So I think these 2 terms, union and intersection, we'll close the chapter today at this particular point. Union and intersection means these 2 A and B are circles, right? Means they are the 2 groups. Everything included in A and B is union, right? What belongs to me, what belongs to you, belongs to both of us. Union, correct? Intersection means only which is common. Let's say mathematics is common between me and you, right? So that is the intersection, sharing knowledge of mathematics. Does it make sense to you? That is how we have to look at it. So the intersection means that thing, correct? Now, it is not necessary that between 2 will have some intersection, right? Let's say male and female. There is no intersection, I mean, if you say, right, in a group. So we say that is a disjoint set, nothing common. Disjoint means separately 2 circles, right? So when I put 2 circles separately, you will probably, that's an exercise for you, right? So therefore they have not put 2 circles separately.
Yeah.
Anyway, they're getting there, correct? So anyway, couldn't find, doesn't matter. So that could be there. But what you have seen here is the similar kind of numbers which were there in my exercise also. So I'll really encourage you to get into more examples, as you can see here. And then we have more examples from previous test papers. And you can watch these examples on my videos and understand all this, right? So there could be a lot of word problems on this particular topic, okay? Now this is not an easy topic. Let me tell you very frankly. It is complicated because sometimes it becomes very confusing what to include, what not to include, right? So clarity is very much required, which only comes with practice. Perfect. So solve all the questions in your book. I will also share with you, in fact, I have shown you already that is my playlist on this Venn diagrams. And we have a couple of playlists like this, right? So this is kind of a level 1, but then you may get into some videos where there are many diagrams shown at the one page, which clearly gives you the idea, overall picture. You understand? So for example, this particular page which you see here, it says shade to represent union, intersection, complements, right? So you understand complements, not included.
Not included, okay.
Right, complement is with that dash on the top. So this is a very good exercise. You just need to shade what is A intersection B. So what is common is that center portion. You know it now. What is complement? Now tell me answer of this one. A intersection B you shaded. Now this one. What is complement of A intersection B? Tell me. What will you shade?
So will you say just the B part? The B part of the intersection?
No, except for this part, everything outside. You get
Oh, okay.
see how tricky it is?
Oh,
Everything
yeah.
outside. Do you get the idea now?
Yeah,
Everything
yeah.
within the universal set. So it's a very beautiful exercise. The second one is A union, not B. You can also read this as not B. Rather than saying B, not B,
Okay.
right?
So, yeah.
So in your mind, but not, I mean, they prefer to use the word complement, but not B is also correct, okay? But thinking wise, it is simpler to use
Okay.
and help you answer the questions. You get the idea, right?
Yeah.
Now the idea here is you have to pause the video. Don't see the answers. So you have to pause the video, answer yourself, and then move forward and check your answers. If you're confused about it, then listen about the explanation. You get my idea?
Yeah, yeah.
See, do you see the complement? Everything green.
Yeah.
That portion.
Ah.
But one slide, one shot of it gives you the whole picture of what could be the combination of complements, union, intersection, whatever.
Okay.
You get the depth of it, right? So that is how we prefer to learn, and I hope you will find it very, very interesting, right?
I will, for sure.
Okay. So that's almost the end, and I think we have covered your first chapter
Yeah.
in a way. We went very fast, so I don't expect you to, understand everything. You need to go through your books, some of my videos, grasp, right, sink in, and let me know by email or by WhatsApp what is not clear to you. So we'll touch upon those things again tomorrow, moving forward. But whenever we move forward, ensure that you have understood everything, right? And keep practicing, and that is going to help us, right?
Okay.
Now sit down and at least for 2 hours work on this particular unit. Yeah, right? So you should nail chapter 1. Whatever difficulties you'll face, address them, and we will actually tomorrow look into those. This is actually one of the most important chapters in your curriculum. So spend time over here, right? Even at grade 12 level, we'll be asking you these questions, which we discussed today. And you'll be amazed that when you see some of my questions there, even in your book, you'll see from test paper of grade 12.
Grade 12, okay.
Yes, so all of a sudden, we are actually beginning from a place which has got a lot of depth in it, right? Do you understand? And utility, because when we talk about the set, everything is in the form of a set. So your foundation first has to be very strong, correct? So it's good that we are starting from here. As we move along, we are actually going to be very, very strong in this topic, and that's good for us. Okay?
Yeah.
So then, how do you find it? Do you find real like?
I like it. It's one-on-one,
like
so it makes being able to understand better.
Yes. So moving forwards, once we get used to one another and understand our requirements better, I think it is going to be even more effective. And I'm doing this with many students, not only in Canada, but in different countries like UK and Germany. And I find that they understand it easily, as if we are taking class in person. So it is as effective as that. Perfect?
Yeah, for sure. Yeah.
Yeah. Great. Thank you and all the best.
Thank you so much. Thank you.
Bye.
Bye-bye.